Celebrating the quantum leap, the 2023 Physics Nobel Laureates. Nobel Awards are given to great professors from all over the world every year. Nobel Prizes have different aspects such as medicine, chemistry, and much more. But today we will talk about the 2023 Physics Nobel Award, the winners, and much more. Let's start.
The winners of the Physics Nobel Awards are Anne Lillier, Pierre Agostini, and Ferenc Krauss. Their research that got them deserving of the prize is the study of experimental methods that generate attosecond pulses of light for the study of electron dynamics in matter. So, what is an attosecond pulse, and what can you use it for? In the early 20th century, quantum mechanics emerged as a groundbreaking theory, but it seemed disconnected from our everyday experience, making concepts like quantum jumps appear abstract. We lack the tools to directly observe and control the quantum world. Fast forward to today, we can manipulate and study individual quantum systems, verifying their existence. We can generate incredibly short pulses of light with advanced laser technology, but atomic dynamics happen even faster on the attosecond scale. This attosecond time scale challenges our ability to directly observe atomic processes, showcasing the incredible speed of the quantum world. To understand how fast atoms are, doing some basic dimension analysis will be enough. The dynamics of the electrons inside an atom are governed by the Schrödinger equation. Anne Lillier, a 65-year-old French physicist at Lund University in Sweden, has been a physicist for over 40 years. Lillier is only the fifth woman to have ever won the Nobel Prize in Physics. With laser technology, ultra-short light pulses are created that make it possible to look into the microcosm. These camera flashes enable the study of the movements of electrons inside atoms and molecules. Her work began in 1987 when she discovered that many different harmonics of light arose when she transmitted infrared laser light through a noble gas. These come to be because the light from the laser interacts with atoms in the gas, transferring extra energy to multiple electrons, which is then emitted as light. Back in 1987, she never thought that this would be awarded by a Nobel Prize, but she still wanted to investigate because she saw the possibility that it could be attosecond pulses. Others didn't think the way she did. However, her intuition led her to pursue the threat. And now we will talk about Ferenc Krauss. Ferenc Krauss is a 61-year-old Hungarian physics professor at Ludwig Maximilian University of Munich, Germany. He has been a physics professor since 1991 and has received numerous awards including the Gale Isaac Humboldt Prize, the William F. Meggers Award, and the Nobel Prize in Physics. Krauss's work was initially focused on creating extremely short flashes of light to visualize the ultra-fast movements of electrons for the first time. Then, he developed the enthusiasm of working with attosecond physics thanks to his vision of harnessing the fundamental research possibilities that this physics branch offers to make groundbreaking advancements in various application areas, from electronics to medical screening devices. Now let's look into the third winner, Pierre Agostini. Pierre Agostini is an 82-year-old Tunisian physics teacher at Ohio State University, America. He has been a physics professor since 1961. In 2006, he presented a method based on the fact that the waves created in HHG method are coherent with each other. That is, they can interfere with the original radiation used to produce them. You might wonder how such a complicated method is relevant to the attosecond physics and why it is wise to use this method. It turns out that the combination of at least two adjacent harmonics and the original light pulse shifted in time allows for the extraction of electrons from the argon atom, which would be impossible if one of the components was missing. Examining the dependence of the energy of ejected electrons on the time shift between the waves allowed us to reconstruct the time structure of the pulses, which were approximately 250 attoseconds wide. This is how the technique called reconstruction of attosecond beading by interference of two photon transitions was developed, and the second part of the prize was awarded for this discovery.
And this is all for now. Thank you for watching this video about the 2023 Nobel Prize in Physics and its winners. Please like our video and consider subscribing. As always, it was Hassel Times.